My name is Monica Rathbun. I work for Denny Cherry and Associates Consulting. I am a Microsoft MVP, and I've been doing this for 20 some odd years. I won't tell you exactly how much, so you do not know how old I am. I am notorious for speaking fast. I am SQL Espresso online for a reason. I am constantly going full speed. I do know for some of you this is English as a second language, so I will do my best to slow down. They cannot guarantee it. I've been trying for years to talk slower and it never works. So my apologies if I talk a little too fast. But this is all of my contact information. You can find me on LinkedIn, Twitter, especially I'm on Twitter all of the time, SQLespresso.com, Mastodon, all the other platforms that are now out there. You can reach me for any questions whenever you have them. These are my presentation rules. I think it's really important when it comes to performance. All of our environments are different. Some things I say may work for 90% of you. The other 10% might have done that already and it caused you issues. So I love to have a presentation in which it's interactive. If I say something and you say, hey, that didn't work for us, let's share that because we learn from each other. Every environment is different and you may actually be able to help some of your fellow attendees here with some of the information that you have. So feel free to interrupt me, ask questions, give feedback. I am completely good for that, including those that are online. Thank you all that are joining for us. And if you need me to repeat something, because I did say it too fast, welcome to do that as well. Okay? Are we good? Okay, so the intended reason for this course is to be able to give you a checklist where you could print out my slide deck, go through your environment, and check and make sure you have all of these configurations set to give you the best configuration and performance that you can get straight out of the box. So we're going to go through each one of these. Some of these you guys may have. Some might be new to you. Some you might say, oh, wow, I didn't know that. So I don't expect it to be all brand new to you unless you're a brand new DBA. So hopefully you'll walk away with at least one thing you can change in your environment and make your boss really happy. So we'll go through best practices first. And this is the number one simple thing that has nothing to do with DBAs. Nothing to do with DBAs. It is all about CPU. It's the power plan. How many of you guys go onto your own laptop and switch your power settings, right? You need to be doing this on servers too. It should always be set to high performance. Most by default are set to balanced. If you are working with other types of servers, maybe it's SharePoint or some other application server, they'll have it set to balance. But for SQL Server, you lose 30% CPU right out the gate if you are not on high performance. 30%. Your entire server has lost 30% power, and you can prove this. There is a tool out there called CPU-Z. You can download it, and you can actually get the clock speed and look at your CPU performance before and after. You will see a 30% difference in the power on that. So not only on your server yourself, every single one of them, including your Azure VMs, you want them on the host. How many of you guys are actually on a VM that's on a host? Right? Have you talked to your admins to make sure the host itself is on high performance? Because you could be losing the 30% on the host box, which is not giving you that full power, and then on top of that, 30% on your SQL Server box. So number one thing to go back and check. Usually it's something that we don't have control over. You have to talk to somebody else to get it changed. They may actually see this grayed out and have to change it at the BIOS level. So there may be a conversation you have to have on that as well to make sure you can take advantage of that. How many of you guys have this changed and do it every time? How many of you have it brand new to you? Never heard of it? Okay, so that's a first. Usually, no one raised their hand. Usually somebody does, and they go back and say, whoa, okay, we got to get our 30% back because that's kind of important. So that's the first thing. And I believe it's so important, correct me if I'm wrong, in 2022, when you do install, I think it actually prompts you for that. It gives you some information on that as well. I was kind of shocked to see that. So next thing, how many of you has had an install in which somebody used the GUI and they did next, 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 checkbox, 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 and they installed all things SQL Server? Yes? How many of you actually gone back to your box and reviewed the services, made sure you're still using all the services that have been installed? SSIS could still be running and nobody's using it, right? So anytime you go to a box fresh, or maybe you're checking it quarterly or you haven't looked at these settings in a while, check and see what's been installed. All of these take resources away from your engine. What's the most important thing we care about? and the performance is our engine. So I don't want any of these taking away resources from that. On top of that, did you know that SSRS and SSIS do not use the memory from the max memory setting that you have inside the, yes, you knew that? Yes. So a lot of people don't know that. They figure they do their max memory setting, we'll talk about that more, they allocate it correctly and they starve SSIS and SSRS and end up starve their window box because they did not leave enough, right? So go through and check and make sure that you only have services running that you need, especially as more and more services come online and people start doing checkboxes. So go through, do that audit, and turn off what you don't need. Patching. Who is on the latest and greatest patch? Nobody. Oh, 2. Wow, I'm impressed. I'm impressed. Are you in the cloud? Yes, and are you not managing it? So those that are online, he said that they do some managing, some not managing. So for most of us, we cannot stay on the latest and greatest patch level, right? We can't do it because it takes an outage, a reboot possibly, or you have to do some testing and make sure there's nothing that's gonna break. But guess what? When you're not on the latest and greatest or near, you're missing out on bug fixes. Bugs cause performance issues. I'm all about performance. I want things fixed. How many of you guys actually read the KB articles that come out with the patching information? Do you really? Do you actually really go through each one? Impressive. Impressive. I don't have time for that. But if you go through and read, you'll see changes to Tempdb, changes to the optimizer, changes to different things with T-SQL code, lots of bug fixes. And you could actually be having performance issues just because you were on a patch level that has a known bug in it. Had you put in the CU, had you addressed it with a certain KB article and done that fix or whatever they instructed you on, you would have better performance. So think more of patching instead of staying on the latest and greatest, security or what have you. Think of it on performance because there's some patches, and I will show you some, that actually make a huge difference in your performance. Now this is so big, when you did 2016, if you were on the RTM version of 2016, the optimizer was no good. There were issues. So you had to make it to SP1 to actually get the real performance gain of going to 2016 in my opinion. You had to be on SP1. So making sure you're staying on not only the latest, greatest patching level, the best and newest possible of your SQL Server edition, right? 2022 has huge performance gains, right? 16 did really well, 17 had a little bit more, 2019 was, whoa, lots of really great stuff. 2022 blows my mind. So staying on the latest, greatest about performance is a huge deal if you can do it. Microsoft support. Who wants to have a major issue? Want to pick up the phone to Microsoft and they say, okay, what version you're on? And you tell them, they're like, not supported, sorry, hangs up the phone, right? So we got to cover our own butts as a DBA. We have to stay on a supported patch level, a supported edition. Anybody here running below 2014 or below? Oh, you'll be calling us and paying high dollar to get that fixed, right? Because Microsoft, unless you have extended support, hanging up the phone on you, right? So it's about that. And I don't want to have the C-level people coming to my office and saying, why were we not on the higher level where we could get support? And now we're down for 3 days and losing millions, right? So patching with that as well. Do we have conversations with our other admins? NIC cards on the VM server hosts, any of the other hardware, are they on the latest and greatest? Is it being patched? Do you have something wrong with your controller because it's on the wrong NIC card or the wrong patch level and it's slowing it down? And that is your bottleneck. Do you know this? As DBAs, it doesn't fall to us, but these are things that affect us. So you've got to be thinking outside the box when it comes to patching, okay? Are we hitting echoes? Okay, good. Everybody still hear me? Okay. Max memory. If your memory looks like this picture, which is the 2478364 value, then you're missing out on a major performance change that you should have in your environment. This is the default max memory, which tells the box, I can use all the memory possible on this box, whatever it has released inside SQL Server. You could run into different issues. Again, if SSIS is running, SSRS is running. Your Windows box, you don't want it to starve, right? You need to be setting the max memory on here. And what does that tell the server? It tells the server you can use up to that max memory value, right? Doesn't mean you're going to use all of it, but when you get to that threshold, that's how much you can use, which is make sure it does not take all the memory from the box, gives it to your OS and your other things that may be running. How do you know what value to put there? There are some magic numbers. It all has to do with math. You don't need to learn that math. There's a couple scripts out there. Jonathan Cahias has a really great script. My coworker John Morehouse has a really great script. They make you look really, really smart when you put a very specific number in there. So you can go and check those out on there. Otherwise, you can say, hey, I'm going to leave 10% to the OS, 20% to the OS, just as long as you are actually doing something with that value to limit SQL Server so it doesn't take everything. SQL Server is the memory hog. It wants all the memory, and we want to make sure that's configured correctly. Again, making sure that you are leaving it for any other services that are running outside of the engine. And you're leaving enough. What value is that? I don't know. It depends on your workload. There are ways that you can monitor how much your SSIS packages are using, how much reporting services is using, whatever it is. Make sure you do that. But multiple instances. Many of you have multiple instances running on the same server. It used to be a thing to save, right? So let's say, okay, Monica says, take the script. I'm going to get this magic number. I look really, really smart. It's 64 gig box. I'm going to make it 48 gigs. That's what the math said. It's 48 gigs. I install it. My coworker comes in, adds another instance. He had to. Ran the script, 48 gigs. I'm feeling smart. And then we look, oh no, we've got all these memory issues. We over-allocated the memory, right? Over-allocated the memory. So it's important when you've got multiple instances that you're looking at what are the instances doing? What are the difference between the instances? Is one heavier than the other? So maybe I put 12 on this one and 32 on the other, or whatever have you, just making sure you do not over-allocate. I have seen it way too many times when I find out there's multiple instances on there that they over-allocated the memory. So if you are in that scenario, go back, do the math. Make sure you are not adding up to the total max value that you have on that server, and you've left enough for those Windows operations to run in itself. Okay? On top of that, lock pages in memory. Do you have that set? It's important for SQL Server. It used to be a best practice to do lock pages in memory. Now there's a lot of information out there on whether that's a good practice or not a good practice, which is why I have a star there. I am not going into the details of why it could be good and bad depending on your workload, but just know when it comes to lock pages in memory, there's some good and bad with it, and you should take a look and see if it's applicable to your workload. Okay? All right. Again, those that are on a VM host, do you have your memory set? Do you have a reservation set? For those that don't know that, is if you have let's say you're working on VMware, you're on a host, VMware, and it says that host, I went to my admin and I said, I want 64 gigs. He says, sure, Monica, I'll give you 64 gigs. He put 64 gigs on there. But he has a box that's limited to 128. So what they do is they put 64, another VM's on there needs 32, and he kind of over allocates the memory because you're not always going to use all the memory that you ask for according to these admins, and they want to actually get as much out of that box as possible. So it has this thing called a balloon driver. And the balloon driver is going to say, hey, this isn't using that much. Let me borrow from that and give it to the one who needs more. And it starts to shift all of those resources. Well, when it comes to SQL Server, I don't want that to happen. I need everything to stay in memory. I don't want anybody to touch my memory. So you need to ask for a memory reservation. That means it's locked, and that host and balloon driver cannot steal that memory back. So that's something simple and easy, out of your control. But when you ask for your VMs to be set up, it's a checkbox. That's all it is. Make sure you ask for it. That way you cannot have it stolen back. Okay? And it's very hard to notice when it happens. I had some that had, it was set at 24 gigs, and it was only getting 12. And it looked like SQL Server didn't have to have more than 12 when we were looking at it, because it never quite made it above it. And we're like, okay, we probably over-allocated this one, or it just never hit the max memory. Well, it never could get to the max memory because it wasn't available. So just something to keep at lookout when you do it. Any questions on this? How are we doing online? We good? Great. Okay, so go back and double check it, do the math, find the scripts to figure out what to allocate and what magic number to put in that box. Tempdb. I do a whole class on mastering Tempdb. you can find the slide deck and everything out there. This is extremely important. So there's a couple things about Tempdb, and there's a couple things that make some changes as we go along here. But if you go to your environment and you only see 2 files here for Tempdb, you have a log file and a data file, you have room for improvement. You want to make sure you have your Tempdb on the best disk possible. Maybe if you're in the cloud, an ephemeral drive or something that you can get the highest SSDs to do all the huge concurrency transactions that are coming through and shared by everybody, because everybody knows you get 1 Tempdb. On top of that, you want multiple files. I'll explain why here in a minute, and I'll explain how 2022 just blows that out of the water. But for now, we're going to pretend nobody's on 2022, and this is what we're going to do. Multiple files, 1 per CPU core, up to 8. 8, it's always a magic number within SQL Server for your cost threshold, right? Your benefit versus cost. Are you doing too much switching behind things in the back? 8 seems to be the right fit for most. There are edge cases for more. But SQL Server does a round robin. It goes through each one of these files and spreads your concurrent workloads to it to try to prevent contention. Everything that happens inside SQL Server, inside Tempdb, is all about contention and everybody vying for the same space. On top of that, we get these special pages, SGAM, GAM, and PFS pages. All of those determine where your workload is going to happen, right? So it looks at these and this says, hey, file number 4, I have space, I'm going to do my workload next. File number 3, this one's going to 2, does all of this round robin thing. So you want to give it as many of these special pages as possible to make the determination. In order to get more special pages, you have to have more files. Everybody with me? Okay, so on top of that, they all should be the same size. You should be going to your Tempdb and looking to see if it's out of sync. If it's out of sync, you have a performance issue. Because why? It's going to say, number 1 has more space because it's bigger. My workload's going there. You lose your round robin. If 1 explodes and you don't have them back in sync, you lost your round robin, the efficient thing of where it's going to do the workload. All right? So that's the number 1 thing. Go back and check your Tempdb. If they're all the same, then the round robin effect and where the workload actually happens helps you with concurrency. Okay? Now, we want to make sure they all grow at the same rate as well, so we keep them the same size. Yes? So the ones that are prior to 2016, there are 2 trace flags that help to make this happen, 1117 and 1118. Those should be on. They're so important that it's handled in previous or later versions, 2016 and above. So what that's going to do is it's going to change how the extents work in the background. It changes it to how the mixed extents works and the pages work. And then 1117 allows them to all grow at the same time. So if one of the data files grow, all of them will grow. So watch your disk space. And that happens on any file that has, or any database that has multiple files. So if you have file groups on another user database on that server that you put those trace flags in, those will grow when they have a growth event. Understand? We're good? So just keep that in mind, that it doesn't just affect Tempdb. Now, remember when I told you patching was important? So it's all about contention and viability and using those files. Well, if you're on 2016 and you have not made it to CU8, or 2017 and you are not on CU5, they discovered that there's metadata problems, right? Everything that we do inside SQL Server writes some metadata, right? System tables write metadata and things like that. They were having contention and locking inside of that. That slowed things down. They fixed it, CU8, CU5. So you have Tempdb issues if you were not on that patch level. So PFS pages, that's how you determine where the free pages are, the next place you're going to actually do the work. And again, SP1 for 2016, CU9, SP2, CU1, and then 17, CU7. If you've not gone to those, you have issues. Any questions? No. So that's just a picture. No, you're not putting those on the C drive unless the C drive happens to be an ephemeral drive that you happen to name or whatever it is. No, it's usually on T. That was on my local, good catch. But no, you want those on the fastest disk possible. Do they need to be all on the same disk? To me, it's a preference. I don't want to share it with any of my user databases. Tempdb should be isolated so we can use all the power. I do put my data files and my log files for Tempdb on the same drive. That's my OCD and keeping it on T usually. So any other questions on that? Now, contention. When it comes to 2022, they rewrote the whole thing about latch contention. So some of the things that were happening is we get a lot of latch weights inside Tempdb. It's got to hold a page, make a determination, and it holds a latch on there. Well, that would slow things down. They have gone and rewrote how that all works, almost to the point where it should be proven that we're going to be able to use the one file and the one file only. So I'm waiting for word for that to actually happen, but my OCD is going to actually put it this way and keep it organized for a while. But it's remarkable. You can go out there and they have several demos on it where it just disappears and Tempdb just is flying now. And you won't need all that extra setup and everything that goes along with it. So important that when it starts to make it into the GUI of an install and it starts to divide out your files, you got to think backwards and say, hey, should this be applicable to my lower environments as well? And this is actually part of the install. Any questions on that? No? Okay, let's talk parallelism. Everyone know what parallelism, we're all DBAs, most of us is, multi-threaded? Okay, so we gotta make sure we treat that with kindness. So when something goes into our environment, if it's going serial, using one thread, and it's pushing all the workload through that. If we go to parallelism, we wanna use multi-threads. So we need to tell SQL Server how many threads it's allowed to use. What's the max DOP, the max degree of parallelism that it allows it to do? Okay, so how do we know where to set that up? It now prompts you in the install for 2019. So again, another very important thing. If you're sitting at 0, you have an opportunity for performance gains, right? You should be changing this. It plays along with cost threshold for parallelism. If that is sitting at 5, you have potential for gains. So how does this work together? One, you're going to actually do your max DOP. I start with the half number of cores. So if I have 8, I'm going to set it at 4. If I have 16, I'm setting it at 8. Up to 8. Again, 8 is a magic number. 8 seems to be a sweet spot for most environments. So you want to match it to the logical processors lower than that. You can actually do this on a statement level. So let's say you set it to 8 because you have 16 cores, and you want one proc to run in serial because it runs faster if it doesn't go parallel. You can do a max DOP hint inside your code and make it go serial. So you can override this, as well as in later features, which you'll learn from my coworker next. They're doing some really great things in 2022 having to do with max DOP feedback, where they start to play with these numbers for you automatically. So this works with cost. How does it work together? A good number is 35 to 50. It says cost has to be 35 in order to go parallel. So it needs to hit each node, I call them nodes or operators inside your execution plan, has to hit that cost threshold. If it does, it's going to spawn out to parallel threads. If it doesn't, it's going to go parallel. I mean, it's going to go serial through that. So what happens is when something goes parallel, you see these things called CX packet weights. We've all seen those. Those are normal in your environment. Knee-jerk reaction is to, oh no, I've got to change this. Too many things are going parallel. It's a good thing. You should go parallel. But what it is let's say my max DOP is 4. I say, okay, it's hit the cost. It's going to spawn out 4 threads. Then it's going to go to the next operator. It's still parallel. It uses those 4 threads as it goes along. As it gets to the final node, it brings those 4 threads back together. The process of bringing those threads back together is a CX packet weight. So if you're going parallel in your environment, you're going to see CX packet weights. If you're taking advantage and going too far out, maybe you're going 8 and it should be 4, you might end up with too much waiting for those individual threads to be available for other operators and nodes to use them. Got it? Yes. Yes. No. So if it's 0, 0 is going to, which is the default, right? It's going to say it can go out as many threads as it wants. It wants to use all 16. It's going to use all 16. What happens when that occurs? Your things might go fast, or you're going to wait on longer CX packet weights because all the 16's got to go back together, or another operation may be waiting for threads to be available and slowed down because you're using too many threads. Controlling this makes it better. And there's always a sweet spot to how many threads something is as far as optimal performance. That's when 2022 comes in, and he'll talk about that a little bit more there. But it's all about making sure when you go parallel, you have multiple threads to do that. Bring them back together, but not too many. Okay, any other questions? 30 to 35 is not a magic number. It's just where I start. If you have max DOP of 1, then you're probably in SharePoint, and you had no choice but to do max DOP of 1. But that means everything's going serial, and nobody's going parallel. Yes? Mm-hmm. So you're talking NUMA now. So that's where I usually just stick with half, and you're pretty safe. If you start to worry about the NUMA aware and going to enterprise and determining what you'd have to know what your NUMA setup is and try to stay within that NUMA. Okay? But so that's the only difference. Usually half is going to be your safe bet still as well. Okay? Yes? So the question is, if I have 24 cores, would max op be 12? Max op is going to be 8. Still 8. So because 8 is the magic number, if 8 does not work, you can go up to 12. You could go up to farther depending on your workload, but 8 is normally the magic number. Then you start to get into context switching, then you start to get into a lot of different kind of weights when you go out too many threads. So, but it's not, out of the realm. It's just 8 would be my sweet spot to start and go from there. Any other questions? Okay. So that is this. They play together. Again, if it's 0 and 5 in your environment, then you have some work to do. So important, again, 2019 is going to help you out with that. When you go through the GUID, it starts to give you some information and says you should be at 8. Or, it tells you the amount of cores. Recommendation is this. You can override it or next through it, and it helps you out. Okay? So this one's simple too. This is out of the realm of the DBAs, but it makes all the difference. Instant file initialization. So important. Again, 2019 is prompting for this as well. So what this allows you to do, and I'll show you in a really easy graph next, is it allows, when you are writing to the file system, it makes you zero out all of the space that you're going to be using before you start to write to it. So that process happens, and imagine if you're making a really big file, it's got to do a lot of zeroing out before it can actually start to do the work. This affects restores, adding new data files, increasing the size. It needs more space, so it's got to zero it all out, and creating a database. Now, if you grant this permission, perform volume maintenance task, it skips the zeroing out part. Huge savings. Really, really fast. So all it is inside your local security policy, user write assignments, perform volume maintenance task, and you add the SQL Server service account. Now you can do that with a group policy as well, but in 2019 there's a checkbox that says, do you want to grant, we want to grant perform volume maintenance task. You hit the check and it applies this for you. Why does it matter? Look at this. So I'm creating a 5 gigabyte database, really small. So right now it takes 1800 milliseconds to do it without IFI, a third of the time with IFI enabled. So imagine that is a terabyte database. It's got to grow. Whatever your growth thing, that can really slow things down, can cause some blocking, whatever is going on in your environment during a growth event, that could slow things down. This is going to make it much faster. Restoring the database, you want to restore as fast as possible. You want this in. Okay, so go back and check that. You may have to go to your administrators to get rights to that or have them add it to a group policy outside of your realm as a DBA. Any questions? Okay. Security constraints possible. Thus, you got to have a conversation with your security admins or whoever's actually taking care of your AD accounts, etc. But it's only on the SQL Server service account. Do some talking and see what you can do from there. Right. So there could be some potential security things to go along with it, but it's a conversation to have. Certainly. But it makes a big difference, and we always check for it when we go onto a new box and take a look and see if IFI is actually installed or not, or enabled. So this I call the magic button of SQL Server. RCSI, Read Committed Snapshot Isolation. How many in the room has experienced blocking? You're fighting fires. You kill somebody, you kill a SPID, and then another one pops up, you kill a SPID, and more blocking happens, and everybody's calling and crying. How many of you actually have a production workload that is not just transactional. Somebody is running reports against it or doing large queries for Power BI or whatever else is getting sucked down through ETL. Almost everybody raises their hand. So what happens is writers block readers and readers block writers. It's just the natural thing You want data inserted, you want to be able to get clean data, no dirty reads, you want to actually have the isolation and blocking. Well, that causes problems for everybody. Nobody wants to be blocked waiting on a report to run for 20 minutes and you realize somebody put in a rogue select statement and blocked all your inserts of transactions. So there's this thing called RCSI, Read Committed Snapshot Isolation. It is so important that it is the default isolation level now in Azure SQL Database. So what this does is it starts to create this thing called a version store. It uses Tempdb, so make sure your Tempdb is configured correctly before turning it on. So it creates a version store inside of Tempdb, meaning if a record is changed in some way, a version of that record, the latest version, is kept inside Tempdb inside the version store. We have access through DMVs to see what's in our version store. Everything's there. So when the select statement happens, it will pull data from the version store if the row is changed. So what does that mean? It means it no longer blocks my table. It is still getting the most current data without blocking, and my inserts can still happen. So it handles all of this transaction isolation really, really, really well. It is a very, very, very far edge case, depending on your application, the way your application code and stuff like that is, where you get these things called race conditions, where it may actually go too fast and you end up getting the dirty read from not being able to get the version store before it's changed and that kind of thing. But it's a far and in between thing. So much, again, that this is the default isolation inside Azure SQL Database. So if you are experiencing blocking, if you have readers and writers on the same database, we all do, putting on RCSI, Read Committed Snapshot Isolation, it is on a database level, it will get rid of your blocking. I can tell you exactly when you've turned it on. When you turn it on, if I'm monitoring your system, because it disappears. It disappears. So big deal. If you can do RCSI, do it. There are a couple things that happen with RCSI. One, who has no lock on every single statement that comes through your environment? Have you seen it? No lock is horrible. I hate no lock. Do not use no lock. If no lock is on your statement, rip it out. No lock will circumvent this. You'll still end up with the dirty reads. Can you go ahead and turn on RCSI without having no lock ripped out? Yes. But then every time you touch a piece of code, start ripping out the no lock. That way you get the full benefit of it. If you're using things like read past or other things with hints where you're telling it to go above and beyond what the isolation level is doing, you'll have to check your code for things like that because it will circumvent RCSI. Okay, but it is definitely the way to go. It's the magic button. Things will start to go faster in your environment, and you will get rid of that blocking. Any question? It's wonderful. You need right-sized Tempdb. So you can keep an eye on how many transactions you've got going through. You can keep an eye on the size of your version store and grow accordingly, making sure your Tempdb is set up correctly first before you turn on RCSI is the way to go. I believe when you turn on RCSI, you may end up having to go into single user mode in order to put it on. Otherwise, you're going to be hanging there for a while waiting for it to get through. That's kind of the downside. It's not really an outage window, but you may end up needing to, depending on your volume of data coming through. But you'll see as soon as you turn it on, world of difference when it comes to the waits that are happening for your application and things like that due to blocking. Okay? Okay. So this is my favorite topic, and everybody jokes me. So all databases rely on other things, right? So we have our network admins that make a difference. We have our architects. We have our storage admins. We have our developers. Everything they do plays a role inside the performance of SQL Server. Whether it's really bad code, whether the storage has actually been determined to be the bottleneck, whether they chose a really bad hardware platform, everything that they do affects our database, yes? Everybody. So how many of you have had to go to another group and say, your storage is our problem, here is the proof, you set something up wrong? Or your code, I performance tune. It is my job to go into companies, make things faster, which means I have to tell you, your code stinks, right? I need you to change your code, and this is why we have to change our code. You have to remove no lock because it's causing dirty reads. No, 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 that's a standard. We have to have that. These are the reasons why we have to have that, and I've got to prove you wrong, right? I call those ugly babies. And for me to come into an environment and point out an ugly baby, we all love what we do. Nobody wants that to happen, but I need the change to happen. So I have a rule. If I'm in an environment, if I go into a company, or if I have to work with the same clients for a long time, I keep them drunk, fat, and happy. Because who doesn't love pizza? Who doesn't love beer? Who doesn't love whatever it is that makes them happy? Donuts in the morning. So if I need to work with the infrastructure team, I need to get more storage. I need them to let me look at their VMware configuration, because I know there's something in there that's probably set up wrong. They're going to say, that's my avenue. You can't look at that. Stay in your road, right? But I need to get in there because I know something is wrong that's causing my stuff to be bad. How do I make that happen? How do I get those other teams to listen to me to get things done and make things better? It is our job as DBAs to get things running as fast as possible, yes? No matter what it is. And we point out other people's ugly babies. So it is our job to learn the key and to learn how to manipulate properly. That's what I say, right? You got to manipulate property. Sometimes that means drunk, fat, and happy. Bring in donuts to the team in the morning before you tell them what the problem is, right? You might actually get things done and get the change happening. So when you ask for, hey, I've got Tempdb, I'm setting up a new one, I need all files to be 100 gigs, right? I need each one. I know it's going to be really big. I need 100 gigs in each file. And they say, Monica, that's not going to happen. No way, no way, no way. I'm going to start off my morning with donuts before I make that ask, or whatever it is, or I have to point out an ugly baby, because I work with people all over the world. Different cultural differences, different ways of what they were trained on. They think they're very, very good at things. They may be. But I still need that work done for my database to go, period. So you got to find a way, whether it's one of these or something else, give or take, to make sure that database runs as fast as possible and could include this stuff. Right? I see some head shaking because we've all been there and dealt with that one person that thinks their stuff is great, but you know it's not, and you have the proof in numbers because the DBA tells us everything, and the database leaves no secrets undone, so we can actually tell what's bad and what's good. So drunk, fat, and happy. Example, virtual environments. Again, if you are actually having your system hosted by another company, or you have another team that actually deals with the boxes, they are taught, when it comes to money and purchasing this hardware, we're going to spend X amount of money on this. You only need this size because nobody's ever going to use what they ask for. So therefore, that balloon driver comes in and they can over-allocate that box. So the box has 128 gigs. They over-allocate it to 256 because no one's ever going to use what they ask for. In that case, they can do this stuff and we don't know. CPUs. I had a client. It was a retailer. The retailer went down. None of their cash registers worked. Went completely down. They were hosted by an outside company. The outside company had all of these boxes, virtual boxes and hosts, that they wanted to make as much money as possible. So they sold and created all of these VMs on the box. Totally over-allocated the amount of CPU threads available on the box. Do you guys remember Spectre and Meltdown? The whole patching that had to happen a few years ago? Anyhow, what happens is that they had all of these CPU cores and threads available, and it was all hyper-threaded. So they over-allocated that box, way over-allocated hyper-thread. They actually had to apply the patching, which took the hyper-threading away, cut the available threads available in half, which means everything went to 100 CPU, nothing could get available threads to do their workload, and it was all because they over-allocated. I don't know that unless I have purview to what's going on my host, because 10 to 1, it's over-allocated. So asking for your, bringing in pizza and asking for access to look inside VMware and see if your box is over-allocated, and having those conversations is what this is about. Because what happens on that busy host affects you. So knowing what's on the host, if they have Exchange at the time, running at the same place that SQL Server is, maybe they're soaking in all of the resources and I need to get that back. How do I know what they have on my box? I need to be asking for access to this to find out if it's over-allocated. So looking for these things, knowing if you are seeing SOS scheduler yields, it's waiting for available threads. that could be an indication of an overallocated box. CPU time is the thing that will go with it, and that's a term that they'll know, CPU time. If you start to see really high SOS scheduler yields, and they say the box looks good, but CPU ready time does not, possibly an indication over allocated box. So you don't know what's going on in the host or what ugly baby is sitting out there without purview. So these are just kind of an example of things of somebody else could have some ugly baby out there that you don't know. You need to get purview too. Same thing with thin provisioning. Do you know what thin provisioning is? No, I didn't either. So let's talk about Tempdb again. So again, I want all of my drives to be the same thing. I go to my admin and I say, I want 500 gigs. 100 gigs on each one of my files, my data drive, my all of my files in my Tempdb or my temp log. 500 gigs. And he goes, Monica, you don't need that. I said, yes, I do. T drive 500 gigs. He says, okay, I'll give it to you. So he presents me a T drive that says 500 gigs. I think I've won the battle. The pizza was worth it, right? But no, what he really did is he thin provisioned it. He gave me 25 gigs per file, but it presents as 100. So in the background, it waits until I get near the 25 and adds more. So I can do up to 500. He presents it as 500, but it really hasn't happened. That's thin provisioning. You do not want those growth events and that extra space added at any point in time that it wants to. So you want it to be thick provisioned when you actually ask for your space. It's another sneaky thing that you don't know about. So asking your admin, can we have all of our drive space thick provisioned is what you want. You may get kickback, but that's what you want. Any questions on that? No? Okay. So compression. This is where they can be your friend. You can actually give them space back, possibly. So compression is a big thing. We want to be compressing our backups. We want to compress our indexes, things like that. Because why? When you compress data, you can get more data on that page, right? We want to have those pages in memory and have the pages in there for as long as possible so we can access that data as fast as possible. So compression is good. It saves space. We can get more data into RAM, keep it in RAM longer, and be able to take advantage of that performance gain. How much compression can you get? There's really wonderful scripts out there that allows you to look at your indexes, look at your tables, see how much space you can actually do by doing row or page compression, and you can actually see the differences in those numbers. So definitely take a look at that if you can do so. Backup compression, of course, you get less space on the disk that you're going to be using. But anytime you have compression, it takes up some CPU speed to get the data uncompressed for you to be able to read it, etc. So there's a cost benefit, but I like to have more data in memory so I can actually use that data quicker and get my results back faster. So the CPU cost doesn't mean anything to me. Okay? Now, one of the things is all this new storage uses this thing called deduplication. You know what deduplication is? It actually dedupes the data on the SAN or wherever your storage is and starts to use these things called pointers. So instead of replicating the data, it uses pointers when it's repeatable data and saves spaces on the storage. Everybody good? That's wonderful. When it takes up the smaller footprint, good deal. However, with backups, when you're doing a backup, you want to make sure you are not doing a backup on a deduplicated SAN. Why? Anybody have any idea? Because when you actually start to create pointers, all of that data's got to come back together, rehydrates, so your restore is longer. Your restore is longer means more downtime. It means more boss over your shoulder waiting for a restore to happen. So a conversation you need to have with your admins again is, our backups, are they on a deduplicated SAN? 9 times out of 10, they're going to say yes, because that's how everything works now. If that's the case, ask and maybe see if you can put your backups offsite on Azure. Put it in blob storage. Is there another place you can put it? If they say no, then I want you to do some testing. Test a restore locally, see how long that takes. Test the restore on a deduplicated SAN, see how long that takes. Make your boss sign off on it, because it will be longer. Save your butt, make sure they know the differences. And when they see those numbers, they may change their mind, and you can put it elsewhere. So that's another thing you want to have the conversation about after you bring donuts in the morning. So, Query Optimizer. Statistics is important. Everybody is managing and caring for their statistics. It is the magic that tells the optimizer how many rows to expect when doing a query and what kind of decisions it can make based on that. The type of joins, if there's any spills that might happen, how much memory is being granted, which operators it's going to actually choose to do that. It is your job to keep these up to date, more than just rebuilding and organizing your indexes. When you rebuild your indexes, you're actually going to get new statistics on that. When you reorg your index, you're not going to. Table statistics, if you've created some multi-column statistics, you want to make sure those stay up to date. You need to be running statistics updates on your environment. How often? Depends on your data churn. How often are your rows changing? You can actually query the database to figure out your row count, what's changed since the last time statistics were updated. So you can keep an eye on that. Sometimes it's an hour, sometimes it's a day, sometimes it's a week. I like to actually update indexes daily if I can, because I want my estimated versus actual rows to be as close as possible so the decisions can be made appropriately and get the fastest performance from my queries. Okay? So, do you have auto statistics set on your database? By default, they are, which is great. What I want you to do now is go a step further. When an auto statistic happens, your system pauses. It gets and waits for a new statistic to occur, which could slow down your query. Just by changing it to asynchronous, gets rid of that pause. So it will actually say, hey, I have a new statistic I need to update. It will wait until your workload is done, send in the update, your next statement will get the new stuff. So instead of being synchronous, it will do it asynchronous, and you still get the benefit. Makes a big difference in performance. That's on a database level, so you need to change it there. Trace flag 2371. If you are prior to 2016, then you have a really, really large table, millions and millions of rows. For auto statistics to actually go in, it's a change of 20% plus 500 row change. Then it'll kick in and give you a new statistic. Well, for a really large table, 20% is a lot. You may be looking at some really old, stale statistics with some data change that you need to account for. Doing trace flag 2371 changes that algorithm to a sliding scale, and you will get newer statistics faster. So that is so important that after 2016, it's defaulted and changed in the behavior. So that's a trace flag you should go back and look at prior to 2016. So missing statistics. Hopefully all of you are looking at execution plans. When you look at the little warnings, sometimes it says, no statistics, missing statistics. We've seen this. Have you taken action on that? When it says that, you should be actually going in, creating the statistic it is asking for, because then the optimizer can make better decisions. So there's lots of times as you developers are developing code, if you know what you're going to be looking for, indexing may not be an option for you. Creating statistics will tell the optimizer you need to grab a little more information on this data, and you can get a better plan. So you can actually create your statistics, especially multi-column statistics where needed. Okay? So indexes. Indexes are a big thing. Indexes are magic. If you got some of those stickers, you've got to make sure you're taking care of them and evaluating your indexes. I had a client the other day. I looked at their indexing strategy on a table. The table had 7,000 rows, and they had 6 indexes on the table. Why, right? You've got more index overhead than you do rows in the table. So how do you negate that kind of stuff? You need to be auditing your indexes quarterly, maybe every single time you do a big release, going through and seeing what indexes are there, what indexes are being used. Are you getting scans, seeks, lookups on your indexes? Are they actually being used as they should be? Can you tweak them? Do you have duplicate indexes? Duplicate indexes is a waste of rights. It gives the optimizer too many decisions to choose from, right? I want to make sure it gets on the right path with the right index that's available. So you should be doing these 3 things at least quarterly. Going through and removing, right-click disable first, script it out, don't remove it right away, and look for any indexes that aren't being used. All of these statistics on the index uses gets reset every time you restart SQL Server. So don't do it after patching, right? If you do some patching and your numbers aren't going to be true to what they need to be. So check for those. Your scans, if you're getting way too many scans on it, maybe your index is in the wrong order. How are the indexes being used? You should be looking at this kind of stuff. Finding the missing index. When you're looking at an execution plan, please, please, please don't right-click, create index when it says missing index, and starts to add all of these indexes in there. Did you know when a missing index is presented to you, it is in table row order or table field order, not necessarily the field order that the index should be put in? So you can right-click, create index. You can verify that all the fields it's telling you to add are actually in table order in the field order, not necessarily what the index should be. So be paying attention to the query statements that you're using and what it's telling you the missing index is on. Make sure you have it in the proper order when you create them, okay? But going through and looking for missing index is the way to do it. Don't actually add every single index that it tells you to do. Covering index, I'm going to show you this. This is really important. When you're going to create a new index, are you always going back and checking on what indexes already exist? Can you add just an included column? Can you modify the order of that index? Is there anything that you can do on that, sorting it differently or what have you, to actually make it faster before you add the new one? Many people don't. They just start to add indexes, and they end up with this big, giant write mess where you're writing too much to your indexes and not doing enough reads from them. So let me tell you how to fix a really easy performance problem. I got 8 minutes. Anyone in this room do not know what a key lookup is? You can be honest. Okay. A key lookup can give you death by 1,000 cuts. It can take your CPU through the roof. I had a client yesterday that had 2 key lookups on their environment, and their CPU was 100%, and they couldn't figure out how to fix it. And I went through Query Store. If you're not using Query Store, I highly suggest you do, and started looking things up by logical reads. What queries had the highest logical reads? And I was able to find out what query was their problem. On top of that, I noticed these things called key lookups. What the key lookup is it says, hey, I've got field select A, B, and C, where A equals 1. Everybody with me? Yes. So I have an index on A. It's just an index on A. So it says there's an index out there. Let me do a seek and find my A value 1 and go use that index. Well, now it needs to go back and satisfy the select statement. The select statement wanted B and C as well. So now it's got to go back to my primary key, match it, and pick up the additional fields it needs, B and C, right? So when you're looking at this, I've got to trip out to my index. Then I've got this thing called a key lookup where it's going to my primary key to get additional fields. It's got to bring it together in a thing called nested loop, and then it returns to my select statement. Everybody following me? So if I hovered over that key lookup, it would say output B and C, which tells me it went to my primary key, it found a match, and just picked up values B and C. Everybody with me? So now let's say I go to my index right there, the index seek on A, and I say, why don't you have B and C tag along as an included column? So now my index is on A, it's tagging along additional fields that I might need to satisfy a select, and it puts it all in one. So what happens is I go from an index seek to a select, and that's it. I remove 2 nodes from my plan, and it'll be a straight across. You can see it happen, and it actually will make an improvement. Why? Because it's possible that in order to do that match on a where clause, is checking all these values and going back and getting to the B and C, it could be 1 billion reads. It could be 1 million reads. It could be all of this additional overhead and CPU cycles it needs to get that information. You can reduce huge performance issues by going back and just getting rid of key lookups. So I challenge you to go to your environment. If you have Query Store, go and find all your key lookups. Or if you're in a plan that has a really bad performance, or you go and look by logical reads, you can find a ton of key lookups. Only changing existing indexes, not creating anything new, adding the included columns, you will massively impact performance when it comes to queries. You could reduce CPU time, you could reduce memory usage, you can make huge impacts by just conquering those. Okay? So on top of that, we talked about missing indexes included statements, or includes with the key lookups. Sorts. For those that are writing the queries, are you sorting every single time you get a data set back? If you look at an execution plan, you'll see sorts are extremely expensive. You could end up with spills, you could end up with memory grant issues, you can end up with a lot of problems having to do with that really expensive sort. I have seen many times where DBAs, developers, or whatever, update, select, sort, update, select, sort, insert, sort, all the time, and at the very end, as you're checking your code, you have all of these sorts just to make sure your data is correct. Well, at the very end, you only need one sort. That's when you're returning the data. Do you really need to sort every single time? It's possible. There might be something that you have to have sort on. But I challenge you to go through your code, remove any sorts that you don't need. huge overhead, huge memory hog. See if you can get rid of them. It's possible that you wrote all of this really fantastic code for an application, and inside the application, it resorts it. Or a report, they sort 5 different ways. So you've wasted your engine's overhead on all of these sorts that you really don't need. So go through and check for those. Key lookups and spills. Spills to Tempdb, those get solved in 2017 and above. He'll talk about some of that. But that's when you actually spill, and instead of having everything done in memory, it goes to disk and it has to write to using the page file or whatever. It might slow you down because your disk may be a bottleneck. So see what you can do to get rid of those as well. So that's all I have. We have about 2 minutes left. Anybody have any questions? No? All good? Hopefully you guys are walking away with something you can go back and check in your environment. That QR code is going to get you my slide deck. Take it back, start having some conversations. Bring your favorite admin a bottle of gin. Have some conversations about how you can get some purview into how the other systems that affect SQL Server affect you. Start talking to your developers, doing code reviews, checking for things for like no lock, checking on indexing strategy. Are your indexes satisfying the queries? Do you have wasted indexes so you're slowing things down? What is your ETL process doing? How long is it taking to write to all of those indexes? Are your ETL processes indexed accordingly so it can actually do the select statements correctly and know what to update? Different things you should be looking at as a DBA to boost performance. And again, making sure your configurations are correct. Any defaulted settings in later versions, go back to previous versions because 9 times out of 10, it's applicable and can save you in performance if it becomes default someplace else. Okay? All right, my cards are up here, plenty of stickers. Stick around for my coworker who will go over intelligent query processing next, right after me. So thank you, everybody. I appreciate that.